Okay. Hello all, welcome to Aai Atc 2024 lecture classes. So today we are going to start with the practice problems for the chapter inverse trigonometric functions. Since it's a very long name, I just wrote the short form. So due to some unforeseen circumstances, we are not able to launch the live class. So as of now, we are going to upload a recorded class of the practice problems related to this chapter. Okay, so this class is mainly meant for aspirants of the exam, Aai Atc exam. So the next vacancy we can expect in this year 2024, which month it can be between August and December. Before August, there's a slight chance, but this is a sure chance. Okay, so if we start preparation now, it's a very good thing. Okay, so what are the syllabus for Aai Atc exam? Okay, the syllabus mainly consists for physics, 11th chapters, 12th chapters, maths, 11th, 12th, aptitude, reasoning, English, and last but not least, GK. The total score is 120, and the cutoff for this exam is always for general category is 99 plus. So we need to aim to score 100 plus in this exam. Okay, so let us move on to today's class. So today's class we're going to discuss the practice problems related to inverse trigonometric functions part 1. Okay, so let us move on to the questions. Okay, the first question is, if sine inverse 2x by 1 plus x square and plus cos inverse 1 minus x square plus 1 plus x square equal 4 tan inverse x, then we need to find the value of x. Here LHS is equal to RHS. Firstly, we need to check whether LHS, the given LHS is equal to RHS. What is 2 tan inverse x? What is the formula for 2 tan inverse x in terms of sine inverse x? Isn't it the same as what's given the LHS, sine inverse 2x by 1 plus x square? Similarly, for in terms of cos inverse x, we write 2 tan inverse x equal to cos inverse 1 minus x square by 1 plus x square. Pardon me for the handwriting because I'm just used to writing this. Okay, I just started with this. So as the class progresses, the handwriting will progress. So when we add these two things, we'll get LHS equal to RHS. So what is the range of tan inverse x? The range of tan inverse x is x belongs to closed interval 0, 1. Isn't that the same as 4 tan inverse x, because 4 is a constant, right? So the answer is this. That is option C. Very simple question. It's a sure question for Aai Atc examination. Note it down. Okay. Now let's move on to the next question. Okay. The domain of the function cos inverse 2x minus 1. First of all, we need to know what is the domain of the function domain of cos inverse x. It's same as sin inverse x, which is minus 1, 1 closed interval, right? That is minus 1 less than or equal to x less than or equal to 1 is the domain of cos inverse x. So when it comes of cos inverse 2x minus 1, the main difference is that it will be like this. Minus 1 less than or equal to 2x minus 1 less than or equal to 1. Here when we find it in terms of x, that will be the answer. Okay, so first we have to eliminate minus 1. So to eliminate minus 1, let's add plus 1 to both LHS and RHS of cos inverse 2x minus 1, right? There just let's add plus 1. What will be there? It will be 0 less than or equal to 2x less than or equal to 2. Now we need to eliminate this 2. Let's divide by 2. 0 less than or equal to x less than or equal to 1. So x belongs to closed interval 0, 1. That's the answer for this one. So this also answer A. That is closed interval 0, 1. Okay. This chapter is very easy chapter. If you know all the formulas, all the identities, all the important formulas of trigonometric functions, trigonometric identities, equations and all. It's very easy. Let's go to the next question. Okay, nice question. The equation 2 cos inverse x plus sine inverse x equal to 11 pi by 6 has. Okay, so here we can write 2 cos inverse x plus sine inverse x equal to 11 pi by 6, right? Instead of 2 cos inverse x, I'm going to write like this. Cos inverse x plus cos inverse x plus sine inverse x equal to 11 pi by 6. Okay, what is cos inverse x plus pi by 6? Sine inverse x, it is pi by 2, right? So cos inverse x plus pi by 2 equal to 11 pi by 6. Okay, so cos inverse x equal to 11 pi by 6 minus pi by 2. Just solve that. Just a second. Okay, so everyone will be thinking the answer will be like one solution because we're only getting one value here, but that's not the case. There's a slight twist here. Okay, twist is like, let's take the LCM and all. Divided by 6, 6 by 6, 1, 11 pi minus 6 by 2, 3, 3 pi, 3 pi, 11 pi minus 3 pi is 8 pi by 6 is equal to 4 pi by 3. So we were getting as like this actually. Okay, cos inverse x equal to 4 pi by 3. Do you think that's possible? It's not possible. Why? What is the range of cos inverse x? It goes from 0 to 0 to pi. Okay, the range of cos inverse x is 0 to pi. 4 pi by 3 is definitely 1 point something pi, right? It crosses pi, so it's outside this. So it's not possible. So the answer will be no solution. Okay, why it became no solution? Because the range of cos inverse x is from open closed interval 0 to pi, which means it can't cross 1 pi. Here we can see it is crossing 1 pi. It's becoming 1 point something pi. So the answer is no solution. I gave you time to solve to check how many people gets it wrong. Okay, instead of wasting more time, let's go to the next question. Okay, this is a nice question. So everyone is familiar with the formula of tan inverse x plus tan inverse y, right? That is tan inverse x plus y by 1 minus xy, right? But here there are three variables, so everyone will be confused. So for those who want, they can study this as a formula. For those, they can just apply logic and give. So I'm just applying with the help of applying logic, I'm just expanding this. That is tan inverse x plus y plus z minus x y z divided by 1 minus xy minus y z minus x z. This is minus. So this is the expansion of tan inverse x plus tan inverse y plus tan inverse z. Okay, so let's apply this, which is equal to pi. Okay, it's equal to pi. That is, so this value which is equal to pi. Okay, I'm just going to put this tan inverse in the RHS. What is tan 90? What is tan 90? It is 0, right? That is x plus y plus z minus x y z divided by 1 minus xy minus yz minus xz is equal to 0. Let's cross multiply. When we cross multiply denominator entirely vanishes, it will be like this: x plus y plus z minus x y z equal to 0. So the answer will be x plus y plus z equal to x y z. Isn't that? They're asking what is the value of x plus y plus z. So the answer is B, x y z. Okay. So very simple question. Just know this expansion. Okay. Tan inverse x plus y plus z minus xyz by 1 minus xy minus yz minus xz. Okay. Let us move on to the next question. Okay, this is one interesting question. Okay. The value of sine inverse cos of 4095 degree. When everyone sees a very big angle like this, they'll be scared. Let me tell a very small short trick on how to do it. What are the possible multiplication table values of cos theta? We know 1 is 0, 1 is 30, 1 is 45, 1 is 60, 1 is 90. Some ultra people like IITians know like 120, 180, 360, etc. But no need of those things. Okay, let's go to the unit digit place of 4095 degree. The unit digit is 5, right? Which of these angles has the unit digit 5 here? 45, right? So we know that 4095 and 45 has some relation. So we can write like this: cos of 4095 equal to cos of 45 plus something. Can we know that something? Simple, just subtract it. 4095 minus 45, 0, 5, 0, 4050. That 4050 has also a relationship of 45. Okay, how we can test? Just divide it. Just divide it and check its divisibility test. No need to follow the divisibility test that you follow in quantitative aptitude. That will take a lot of time, right? 45. We know that 45 into 9 is 405, 90. So can't we write like this? Cos of 45 plus 90 into 45. Isn't that same as cos of theta plus pi by 2? That is cos of pi by 2 plus theta. What is it? Minus sine theta, right? Because 90 into 45 means it's a multiple of pi by 2, right? That's why I wrote as pi by 2 here. Okay, it can be like pi by 2 into 45. It's a multiple of pi by 2. So cos of pi by 2 plus theta is minus sine theta. Okay, so we can come here and instead of cos of 4095, we can write like this: sine inverse sine minus sine 45, because here theta is what? What is theta? Theta is 45 degree. See. So what is sine 45? Minus 1 by root 2. So it will be like this: sine inverse minus 1 by root 2. Sine inverse of minus sine x is minus sine inverse x, right? So 1 by root 2, it's pi by 4. So pi by 4. This is the answer. Answer is option C. Very simple question. If you know the identities and just some short tricks, you'll be able to solve this. Okay. Now let's move on to the next question. Okay, interesting question. 2 tan inverse cos theta equal to tan inverse 2 cosec theta. Okay, now let us. Okay, so this question is actually an NCERT question. I took this question because by many analysis of previous year ATC exams, we can see that 5 to 10 questions of NCERT questions are being repeated, the same exact questions. That is, they won't take the MCQ questions from NCERT textbooks just like that. Instead, they will take questions like these and convert it into a MCQ question. These are the questions we will just eventually skip because there is no proof that questions show that questions in ATC exams. So what they do is that they will formulate the question like, if 2 tan inverse cos theta equal to tan inverse 2 cosec theta, what is the value of theta? They will give 4 options. See, a question is formed. So better we just read through those questions. I'm not telling you to work out, read through those questions, because important ones I will be discussing in each classes. That's why. Okay. So we know the expansion of 2 tan inverse x in terms of tan inverse x, right? Why I'm expanding in terms of tan inverse x? Because there in RHS it's given in terms of tan inverse x. We can cancel it out. That's the purpose. So tan inverse 2x by 1 minus x square, right? So we can write like this, that is 2 tan inverse, let me write down the question first, 2 tan inverse cos theta equal to tan inverse 2 cosec theta. Okay, so for instead of 2 tan inverse cos theta, we can write like this, tan inverse 2 cos theta by 1 minus cos square theta equal to tan inverse 2 cosec theta. Okay, let me cancel out. See, I cancelled out. If you want to go cancel out this 2 as well, cancelled out. Okay, cos theta by, what is 1 minus cos square theta? Sin square theta equal to cosec theta. Cos theta, let's take sin square theta. We know that sin theta into sin theta. Cos theta by sin theta is cot theta into 1 by sin theta is cosec theta equal to cosec theta. Cancel out. Let's write the remaining here. Cot theta equal to 1, theta equal to pi by 4, because tan theta and cot theta has the same value, pi by 4, for the value 1. See, simple question, right? During exam we see this question as like a tough question, because everyone will be confused like how can we expand 2 cosec theta, because if you don't know a particular identity, leave it as that, because eventually when we solve and come, we will get a chance where we can cancel it out. Okay, let's go to the next question. Which of the following is the principal value branch of cos inverse 6? So during exam, everyone will be worried that they haven't studied the principal value branch like by heart. What I'm saying is that there's no need to study that, because in the previous video, I have explained that we must know the domain and range values of cos inverse 6, right? So what is the domain of cos inverse x? Domain of cos inverse x, we discussed this domain value in the previous problem as well, because in many questions, domain of cos inverse x, it's being repeatedly asked. That is, they won't directly ask the value, but application of those. Okay, domain of cos inverse x. What is domain of cos inverse x? Post interval minus 1 comma 1. So when we draw the graph, we mark minus 1 here and 1 here. In which particular angle we get cos, in which particular angle of cos we get minus 1? Cos pi, right? Cos 180, that is 180 degree, right? In which we get 1? Cos 0, right? So what's the answer? We got the answer. It is from 0 to pi, closed interval. So the answer will be option C. That is the principal value branch. It points to the domain value. That is the angle of the domain values. Okay. Next question. Okay, nice question. 3 tan inverse x plus cot inverse x is equal to pi, then x equals. This question is also an easy question. Everyone will think it's a tough question. Okay, we know some identities based on tan inverse x plus cot inverse x, right? Like this tan inverse x plus cot inverse x equal to pi by 2. With the help of this, we can solve it. And also we know an identity like this, 2 tan inverse x equal to tan inverse 2x by 1 minus x square. We just discussed that in the previous problem, right? So 3 tan inverse x, I can write like this. 2 tan inverse x plus tan inverse x plus cot inverse x equal to pi, right? So 2 tan inverse x, I can substitute like this. Tan inverse 2x by 1 minus x square plus pi by 2 equal to pi. Let's push this pi by 2 into the RHS. We get pi minus pi by 2. What? What is pi minus pi by 2? 2 pi minus pi by 2. Tan inverse 2x by 1 minus x square equal to pi by 2. Let's push this tan inverse to the RHS. We'll get like this. 2x by 1 minus x square equal to, what is tan handy? Infinity. Infinity, what is, how do we define infinity? We, sorry. We define as 1 by 0. That is infinity, right? This is 0. We will get like this. Okay, like this. That is 1 minus x square equal to 0. Minus x square is equal to minus 1. X square is equal to 1. X is equal to plus of minus 1. And also, some of the institutions, they will tell we can solve this particular questions using option elimination, but it will take a lot of time, that is going through each and every options. But by arriving at this answer, we know that option A and option D are wrong. Either it will option B or option C. So we can take, with the help of our hunch, I'm going to go for the first value, option B, that is 1. Let's say when x equal to 1, okay, what is 3 tan inverse 1? Tan inverse 1 is pi by 4. Those 3 tan inverse 1, 3 pi by 4 plus cot inverse 1. We have discussed in the previous problem. It's pi by 4. What is 3 pi by 4 plus pi by 4? 4 pi by 4 is equal to pi. We got the answer actually. We don't need to check for minus 1 because only one option is correct at a time, right? So let's go for option B. So for those who think minus 1, we need to go. You can go for first, but eventually you'll get it's not possible. So you have to go for 1 again. Okay. Okay, so this is the answer for this question. Okay, so let's go to the next question. Yes, this is also a simple question. Cos of sine inverse 2 by 5 plus cos inverse 6. There's no need to expand the inner bracket and all. So what we need to do is that firstly, just write down what data is given. That is cos of sine inverse 2 by 5 plus cos inverse 6. Okay, the reason to write down is that it will be easy for us to do what's next. Let's put this cos in the RHS and see what happens. Okay, sine inverse 2 by 5 plus cos inverse x equal to cos inverse 0. What is cos inverse 0? We get 0 for cos inverse x in the angle pi by 2, right? So, and also we can write like this. We need to find the value of x. So let's put x in the LHS and put the sine inverse 2 by 5 in the RHS. Pi by 2 minus sine inverse 2 by 5. We can convert these RHS into terms of cos inverse x. How? With the help of this identity. Sine inverse x plus cos inverse x equal to pi by 2, right? With the help of that. So we will get like this. Cos inverse x is equal to cos inverse x is equal to cos inverse 2 by 5. Cos inverse cancel. So x equal to 2 by 5 is the answer. So answer is option B. Let's go to the next question. Okay. The last question. I think this was the first question, so no need to repeat that. This is the last question for today's class. Okay. Tan inverse x plus tan inverse y is equal to 4 pi by 5. Then we need to find the value of cot inverse x plus cot inverse y. Now first of all we have to write the given data down. Okay, for beginners you can do that. For experts, go with the question. But here I recommend that. Okay, so tan inverse x plus tan inverse y is equal to 4 pi by 5. Okay, so for tan inverse x in terms of cot inverse x, we can use with the help of this identity. Tan inverse x plus cot inverse x equal to pi by 2. So for tan inverse x, we can write like this. Pi by 2 minus cot inverse x plus pi by 2 minus cot in cot not cos cot inverse y equal to 4 pi by 5. Okay, so pi by 2 and pi by 2 eventually will be added up to like pi. Cot inverse x plus cot inverse y, we can put like minus outside and put like this: cot inverse x plus cot inverse y equal to 4 pi by 5 minus pi. Let's put this minus in the RHS. We'll get like this: cot inverse x plus cot inverse y is equal to pi minus 4 pi by 5. 5 pi minus 4 pi is pi by 4, pi by 5 answer. So we got the answer: cot inverse x plus cot inverse y. Answer is A. So this is it for today's class. I hope all of you understood the class. So for those who are weak in English, they can switch on English subtitles and go through the class. If any doubts, you can post in the comment section or in the Telegram group. The link of the Telegram group will be posted in the description. So thank you guys. Have a nice day. We have discussed around 10 questions for the chapter ITF. More questions will be discussed in the upcoming classes. Similarly, physics portion chapter-wise explanation with important formulas, important concepts, practice set questions will be explained soon. So thank you guys. Have a nice day.